One quick note here, in normal Gendl usage, most objects are created, we say, on the fly. That means on demand, automatically, as child objects of other objects. So normally you will not explicitly call makeObject by yourself. In a typical application, even working at the command line, you will only call makeObject once for a root level object. One main object at the root of what becomes a tree that's made up by children and grandchildren and so on. And those children and grandchildren become instantiated automatically when you ask. You do not use makeObject explicitly by yourself normally. Now here's another section for the specification list. So now we have two keyword value pairs in the specifications. We have our computed slots like we did before. So there's the keyword and there's the value for it. But now we have another pair which is called input slots. The keyword is input slots and the value in this case is a list with a single symbol. So input slots are similar to computed slots, but they do not have to have an expression. So they do not have to have their own list. Like with gamma, it's inside its own list because you have the name and then the expression. So it needs a list to contain the name and the expression. For temperature, it's just there by itself. That means temperature is a required input. So it does not have a default expression. So when we create an object, when we do a make object of speed of sound at temperature, we have to we do make object just like we did before with a quoted symbol, but now as additional arguments we have a keyword argument, temperature, with a value that you specify when you actually make the object. And this is how you do it with make object. We'll see how you do it with child objects in a few slides. So notice that when we specify, we'll go to the code again now. When we specify the input slot, it does not have a colon. It's just the symbol, temperature. And I'll go ahead and compile and load this. I put the cursor at the end, Control X, Control E. So now we have sound at temperature. Now over here we can do a make object, and I'm going to make a full-size buffer for a minute so that we don't cut off. Control X1. Set object to make object speed of sound at temperature. And now in this case I'll add to this the temperature as a keyword argument, and let's say 255. So now I have an object whose temperature is 255. Now I can ask for the object, let's say temperature, to confirm, yes, its temperature is 255. And now let's ask for its speed, which will be affected by that temperature. And there's the speed, 9.2722. Now let's make another one and put the temperature at 273. That's the original temperature that was in the speed of sound object originally. Now let's ask for that object's speed. And that's different. And that speed should match the speed in the original speed of sound object.